So now we move on to inequalities, and we're going to start with linear inequalities, which are the easier ones to solve. So first of all, your calculator doesn't solve linear inequalities. It does solve a different type of inequality though, which we'll talk about in a sec, but it doesn't for linear. So the way you solve linear equalities is by making x the subject, or the variable the subject, because obviously it won't always be x. So let's take an example. So the question will usually be framed as something like find the set of values that satisfy, and then it will give you a inequality. So let's use for this example 2x plus 5 is less than 3x plus 2. So the way we solve this is just make x the subject. So we're going to move the 2x onto the other side to do 5 is less than x plus 2. Remember that the way it works with the algebra is it's the same as an equal sign, as you can just move stuff to the other side, etc. And then you move the 2 onto the other side to get 3 is less than x. And that's the final answer. The inequality up here is true when x is greater than 3. Now, really quick, I just need to differentiate between two signs. This is equal to greater than, and this, with the line underneath, is equal to greater than or equal to. So for this example down here, x cannot be 3. It can be 3.1, it can be 3.2, but it can't be 3. If it had the line underneath, though, that would signal that x could also be 3 as the value. A very important point to remember with inequalities, and I always forgot this, and I guarantee you're going to forget it at some point as well, so please try and just ingrain this into your head because it's very easy to forget, is when you times or divide by a negative number, you must flip the sign of the inequality. So for example, let's do minus 5x plus 3 is less than 4. Remember, it will have the same setup as the question where it says find the set of values that satisfy, but I won't do it here, so it'll take forever to write. But you have the same setup. So in order to do this, you have to make x the subject, so it'll be minus 5x is less than 1. And then you need to divide everything by minus 5. So it'd be x, and then the minus 1 over 5 over here, because you're dividing everything by minus 5. But you have to flip the sign. You still include the minus over here. You still include the minus over here, but you have to flip the sign. And this here is the final answer. For this inequality to be true, x must be bigger than minus 1 over 5. So a very common exam question they can ask at you is that they will ask you to combine, they will combine inequalities together. They will give you two inequalities and they want you to find solutions for when both of them are true. So they'll frame the question in the same way, something like find the set of values that satisfy, and we're going to say 3x minus 5 is less than or equal to x plus 8, and 5x is greater than x minus 8. So find the set of values that satisfy the first inequality and the second inequality. So they want you to find them when you can satisfy both the inequalities at the same time. So the first step is just solve both of the inequalities individually. So for the first inequality, 3x minus 5 is less than or equal to x plus 8. If you move the x onto the other side, you get 2x minus 5 is less than or equal to 8. If you move the minus 5 onto the other side, you get 2x is less than or equal to 13. And if you divide everything by 2, you get that x is less than or equal to 13 over 2. And that is the solution for the first inequality. For the second inequality, we're going to move the x onto the other side to get 4x is greater than minus 8, and then divide everything by 4 to get that x is greater than minus 2. Remember that we're dividing by 4, so we don't need to flip the sign because we're not divided by a negative. So these are the solutions to the individual inequalities, so that's good, but we need to find the solutions for when both of them are true at the same time. So there are kind of two ways that you can do it. So the first way that I do it is kind of just completely in my head, but I'll kind of show you the way that I work it out in my head. So what I do is I put x in the middle for both of them. So x is greater than minus 2, and then x is less than or equal to 13 over 2. And then I'm going to rewrite this, so I kind of put both of the inequalities in the same direction. So remember, for this top one, there's another way you can write this. X is greater than minus 2, and if you just flip this around and say that x is greater than minus 2. Remember, these two things here are the exact same. They both represent x is greater than minus 2, and then I'm going to keep writing this the same, where x is less than or equal to 13 over 2. And then what you can actually do is kind of merge these and find the solutions for when these are both true. You can find the small range in which, for the first inequality, is true when, for the second inequality, everything is true when x is greater than minus 2. Of the second inequality, everything is true when x is less than or equal to 13 over 2. So if you merge these, you can find the small inequality where they're both true at the same time, where x is bigger than minus 2, but is less than or equal to 13 over 2. And if you think that about that in your head, that makes complete sense. And that's the final answer, the solution, the set of values for when both inequalities are true. The second way to do it is the one the book says, is by using a number line. I find this a bit long-winded, to be honest, and I think it's a bit unnecessarily long. So if you like it this way, the way you can do it is by drawing out a massive number line and putting out the two values. So we'll put minus 2 about here, and we'll put 13 over 2 about here, so that will put 0 about here for reference. So for the first inequality, over here, x is less than or equal to 13 over 2. So x is less than or equal to 13 over 2. So x is all the values under 13 over 2, but remember it also includes 13 over 2, so we're going to shade this in here, and the shaded in represents equal to, so the shaded dot represents equal to, and the non-shaded is not equal to. And then for the second inequality, x is greater than minus 2. Well, the way you do this is you draw the dot here, and then x is greater than minus 2. We won't shade the dot in because it's not equal to, it's just there's no line underneath. And then what you can do here is you can find the range for which both of them are true when both of the lines make sense and both of the inequalities overlap. And you can find this quite easily by saying that minus 2, which is the dot here, x is greater than minus 2, but it stops here, so then the x is less than or equal to 13 over 2, because remember there's the dot here. You can do it that way if you want. For me personally, basically explaining that is kind of the exact same length that you're going to do it in an exam. So I would say try and find a bit of a quicker method to do it than that. But if you want to do it that way, it's much more important for you to get the answer right than to spend an extra couple of seconds on it. Let's do another example when you have to combine inequalities. So let's pretend we've done the first step already. We've solved the inequality, and we've got the two final inequalities as x has to be greater than 3 and that x has to be greater than minus 1 over 5. So obviously you can do it by the number line method if you want, but I'm just going to do it by my method. So again, we write the x in the middle like that, so that 3 is greater than x, and then x is greater than minus 1 over 5. We want to get them both in the same direction, so we're going to flip this one on the bottom here, because the inequality sign here isn't in the same direction. So we're going to do that now, and we're going to do that x is greater than 3, and if we flip this around, we'll get that x is greater than minus 1 over 5. Remember that these two are the same because they both represent x is greater than minus 1 over 5. And then if we merge these together, you'll actually find that the only the solutions where both of them are true is when 3 is greater than x. X is greater than 3. this is the final solution here. If you think about that, that's true, because for all the values under 3, between 3 and minus 1 over 5, okay, it will satisfy this inequality, but it won't satisfy this one up here, will it? It won't satisfy it. So therefore, the only values for which both inequalities are true is when x is greater than 3. You can obviously represent this on the number line as well, and you'll basically see a similar pattern where I won't draw the number line, but you'll see it kind of this way, where you'll find the overlap. This part here doesn't work because you don't have the line up here, but this point here you have the overlap. That's kind of what this is saying up here. So the solution is when x is greater than 3.